Okay, moving on now to examples of expected value and how you would actually calculate that average gain or loss. Let's say you buy a raffle ticket for $20 and there are 4,000 tickets being sold. One ticket is going to win $3,000 in groceries. So, what is the expected value for this raffle? So, if you win, if yours is the ticket that's drawn, again, you paid $20 for your ticket and you get $3,000 in groceries. That will be a $2,980 overall gain for you, just taking out that $20 purchase price for you. If you don't win, you lose your $20 or a negative 20. Okay? The probability of winning that raffle is 1 out of those 4,000 tickets that were purchased. The probability that you don't win is the 3,999 out of the 4,000 tickets that are not going to be drawn. So expected value is found by multiplying the outcome, which is the gain or loss column, this is the outcome, by the probability of that outcome. So what we're going to do is we're going to take that gain or loss, multiply it by the probability of the outcome, take the gain or loss, multiply it by the probability of the outcome, and we're going to add those results together. So take 2,980 times 1 over 4,000 and add to that negative 20 times 3,999 over 4,000, and we will find that we come up with a loss of $19.25. So in other words, for the 4,000 people who enter this raffle, on average, each one of them is going to lose an average of $19.25. Okay, moving on to an example with the lottery. So let's say there are 42 balls numbered 1 to 42. They're put in a machine and 6 are drawn at random. If the 6 numbers, or a player matches all 6 numbers, they win $500,000. If they match 5 numbers, they win $5,000, and a ticket costs $1. Okay, so if they match all 6 numbers, they're going to win $500,000. But again, they did pay $1 for their ticket, so their gain is $499,999. If they match 5, they're going to win $5,000, but again, they did shell out $1 for their ticket, so they walk away with $4,999 profit. And if they lose, then they're out their $1 lottery ticket. Now, how do we find the probability of that outcome? So if they're going to match all 6 numbers, the numerator is going to be, out of the 6 winning numbers, they happen to have all 6 on their ticket. The denominator is how many different sets of 6 numbers could have been chosen in order to win this lottery. So 42 numbers, choose 6. And it does say in any order, so order doesn't matter. So the probability of having that winning number is 1 out of 5,245,786. Okay. The probability of matching 5 numbers is going to be, of those 6 winning numbers, you had 5 of them, so you get to pick which 5 of the 6 numbers are going to match, and then you must have 1 number that doesn't match any of the winning numbers. So of all of those numbers that are not part of the winning number, there are 36 non-winning numbers, and you have 1 of them on your ticket. So 36, choose 1. And our denominator is still 42, choose 6, for a total of 216 over 5,245,786. Okay, now to come up with all the ways to lose, notice here that there's one way to win all 6 or match all 6 numbers, and there's 216 ways to match 5 of the numbers. That means all the remaining outcomes must be ways to lose. So remember, there are 5,245,786 possible outcomes. If you subtract the 217 different ways you could win some amount of money, that leaves us with 5,245,000 569 different sets of numbers that are losing numbers. You're not going to win anything. And again, that's found by taking that denominator and subtracting the 1 that matches 6 and the 216 ways that you can match 5 of those numbers. Now, just like we did before, we've got our outcome here. That's our first column. We've got the probability it happens. So multiply that gain or loss by the probability, the gain or loss by the probability, the gain or loss by the probability, and add all of those up. And we will find that on average, we are expected to lose 70 cents every time we play the lottery. Now, what I'd like you to do is pause the video and see if you can figure out what happens in this next example. I will give you a little hint that on the far left, you should fill in those columns with the person lives or the person dies. See if you can figure out what the gain or loss is and the probability it happens, and then if you can come up with the expected value. Then restart the video and you'll hear my explanation. Okay, let's see how you did. Now, when you're buying insurance, if you live to see the next year, you just paid for that insurance and you didn't get anything back. So if that person lives, they're out their $600, okay? If that person dies, then they, or more specifically, their beneficiaries will gain some money, but because that $600 policy had been paid, basically the benefit is $299,400. Now, the probability that a 43-year-old woman dies is 0.17%. So notice here, I have gone ahead and reminded you how to turn a percent into a decimal. You need to take that decimal point and move it 2 spots to the left, which is how we move that decimal over there. So the probability is 0.0017. So the probability that that woman lives is 1 minus the 0.0017. So basically 1 is the probability of living and dying combined. We're finding the complement of that, so 0.9983. Multiplying the gain or loss, so the loss of $600 times the 0.9983, and then the gain of $299,400 times the 0.0017, we will find that on average, that 43-year-old woman buying this policy loses $90 a year on her policy. The flip side of that is the gain for the insurance company. So for every policy for 43-year-old women that they write, such as this one, they're making $90 average on each policy. And what that does is it allows them, when a 43-year-old woman somewhere in the country dies, it allows them to then pay that woman's survivors and her beneficiaries that money. That's how insurance works.